my name is Darian Keaton, and today I will be talking about Isaac Newton's discovery of the three laws of motion. First off, I just wanted to say how proud I was of my team for putting together such an amazing presentation. So let's jump into it. Newton's third law of motion, action and reaction. Newton's third laws explain that forces always come in pairs. Whenever one object applies a force on another, the second object applies a force on equal strength in the opposite direction. This principle is often explained as for every reaction, there is an equal and opposite reaction. It means that no force acts alone. Every action results in a reaction. The areas influenced in this is that these laws play a vital role in fields like physics, engineering, biology, athletics, and daily routines. The applications in this are propulsion systems in aircraft and rockets. Gases expelled backwards generate an equal force that propels the vehicle forward. The space level is another one. The downward force of a rocket exhaust results in an upward motion, lifting the rockets into space. Everyday examples include walking, pressing your feet against the ground, which in turn pushes you forward with equal force. In 1666, Isaac Newton introduced the three fundamental laws of motion, which became the foundation of classical physics. The first law states that an object will remain at rest or keep moving at a constant speed in a straight line, unless acted on by an external force. The second law explains that the force applied to an object caused it to accelerate in the direction of that force. The acceleration is directly proportional to the force and inversely proportional to the object's mass. The third law states that for every action, there is an equal and opposite reaction, meaning forces always occur in pairs.
Experimental process / impact. Original. Experiments colliding pendulums. Newton collided two pendulums of different masses, measuring the forces and rebounds to understand how forces affect motion. Observations on planetary motion. He studied the orbits of planets. Difficulties. He spent his time alone, which led him to have trouble collaborating with other scientists. He often ignored factors like friction and air resistance. He had a bad temper, which affected his mental state and productivity. Motivation. Simplification of objects, mathematical approach, understanding natural laws, universal laws of motion. Benefits. Foundation of classical mechanics, simplification of physics, unified understanding, big influence on science and society, and unsolved mysteries of the universe. Experimental process / impact modern. Newton's third law provides the framework for understanding and predicting various outcomes to different interactions. Experiments. Elaboration with non-Newtonian systems like brain behavior that may defy the laws. Applications like aeronautics and robotics. Newton's law of motion has been an essential building block to classical mechanics, equipment analysis, vehicles, structures, and technology. Example question, motivation. Question, how did Isaac Newton's discovery shape modernization today? Relevance, shaped technology, engineering, and science today. Benefits, understanding the theory of motion, understanding modern calculus. Uniqueness, laid foundation for mathematics, changed our understanding of the world and how it works. Motivation, how motion has changed on life.
Hello, my name is Jacqueline, Jackie for short, and ironically, I'm going to talk to you about Newton's third law of motion and how we both, literally and figuratively, put a plan into motion. We first begin by connecting with each other to brainstorm an example question and the process in which to solve it. We feel that Newton's third law of motion matters and can make a difference in the world if people understood the process of motion and how we use and rely upon it in our everyday life. We studied the question of if a swimmer pushes off a wall with a force of 100 newtons, what force does the wall exert back and what happens? This is relevant because it shows action and reaction in everyday motion, also while explaining how equal and opposite forces cause movement. This example is unique because it demonstrates how forces come in pairs. When a swimmer pushes off the wall at 100 newtons, the wall pushes back in the opposite direction at 100 newtons. Newton's third law of motion demonstrates that when two objects collide, there will always be an opposite reaction, whether they explode, push each other back, or merge into one. In summary, forces will always be in pairs. One object cannot exert a force without experiencing another force. For any further elaboration, please refer to the reference listed in the following slides.